All right, now we're in the radical section. Woo! All right, so first things first, if we're talking about a square root of a number a, we're going to write it like this, right? Square root of a. And if square root of a is some number, that's the same thing as saying, right, that b squared is a. So if a squared is some number, that's the same thing as saying b squared is a, right? Because, for instance, the square root of 9 is 3, right? And then we also know that 3 squared is 9. So same thing. If we have a cube root, then that means instead of just writing this sign, we also have to put a 3 right there. So that's the cube root of a. And hopefully you can see the pattern. If the cube root of a is equal to some number b, then that means that b cubed is equal to a. So again, if you see the cube root of 8 is 2, then 2 cubed is 8. Because 2 cubed, 2 times 2 is 4, times 2 is 8. So the cube root of 8 is 2. And we can actually keep going for the nth root. Right? So n is just some number. It could be 2, it could be 3, it could be whatever. And this is how we would write it, right? The nth root of a. So any number root, right? If that equals b, then we can just know that b to the n is going to be a. So that's kind of the general form. Hopefully you can see that pattern. This symbol right here, we call that the radical sign. So if it's a square, we can call it a square root sign. If it's a cube root, we can call it a cube root sign. But in general, we can just call all of them radical signs. The n is what we call the index. And this is going to be very important. So if the index is 2, this is going to be represented as a square root. And it's not written. So just like how if you have an x, right? You know the coefficient in front of it is 1. You don't have to write that. So same thing. If you have radical x and there's no index here, we just assume it's a 2. The 3, of course, is going to be the cube root. Right? And we already talked about that. Oops. All right. We also say that the number a under the radical sign is called the radicand. And then this whole thing is called the radical expression. So this whole thing is called the radical expression. All right, let's talk about simplifying radicals in general. So first things first, you want to break up the radicand. So break up what's underneath the radical as a product of two factors. You break up each of the factors into a product of two factors until you end up with only prime numbers, right? So we're just doing that prime factorization again. Then you want to circle identical numbers in groups of the index n. So n is actually going to tell you how many people need to be, or how many numbers need to be in a group. So if it's a square root, right, you're going to need 2 numbers. If it's a cube root, you're going to need 3 numbers in a group. If it's the 100th root, you're going to need 100. For every group that you circle, 1 number will come out of or outside the radical. Step 3, we multiply all the numbers outside the radical, and we multiply, step 4, all the numbers that were left inside the radical. Then we just put it all together in one term, where the product of step 4 is make sure, again, that's under the radical. All right, so let's look at some examples. So example number 1, part A, the cube root of 64x cubed. So let's break up 64. Well, we can see that that's 8 and 8. 8 can be broken up as to 4 and 2, 2 and 2. 8 is 4 and 2, 2 and 2. We can also see that the x cubed gets broken up into just x times x times x. So looking at the index, we see that this is a cube root, which means that we need 3 numbers to be part of a group. Well, we can see that from this one, right? We get 2 times 2 times 2, 2 times 2 times 2, times 2 times 2 times 2. So here's one group of 2's, so a 2 is going to come out. Here's another group of 2's, so a 2 is going to come out. Remember, we're going to multiply these. And then here's a group of x's, right? 3 x's, so an x comes out. And there's nothing left. So we see that that answer is going to be just 4x. Part B. So we have the cube root of negative 54. Well, first, notice, right? If you remember a cube root, if it equals some number, that means that this number cubed is negative 54 x cubed, right? This number cubed is negative 54 x cubed. So, if you have an odd number of things and it ends up being negative, is that okay? Well, notice that negative 1 times negative 1 times negative 1, right? So negative 1 cubed. Negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1. So, yeah, you actually can get a negative if it's an odd power, index. So really, if you have an odd index, this negative can just come out. So we can take out a negative 1, and now we're just looking at 54 x cubed. So 54, that can be 6 and 9. 9 is 3 and 3. 6 is 2 and 3. If we have a group of 3's, right, we need 3 numbers. So one group of 3, so we know a 3 can come out. And then with the x cubed, we see 3 x's. So an x can come out. And then we still have a 2 left inside. So remember, you need to make sure it's not just square root of 2. Remember, you got to keep those indexes. So the cube root of 2. So in total, we get negative 3x times the cube root of 2. And that's our answer. And if you go backwards, right, that makes sense too, because you could do negative 3 times negative 3 times negative 3 is going to be negative 27 times 2. This is negative 54, which is what we were wanting. All right, let's do this one. So the fourth root of 81. So 81 can be broken up into 9 and 9. 9 can be broken up into 3 and 3, 3 and 3. So how many need to be in our group this time? Since it's a fourth root, we need 4. And looky there, there's a group of 4 3's. So our final answer is just 3. Negative fourth root of 81. Well, we already know what the fourth root of 81 is. We said it was 3. So we can just substitute that, right? So our answer is just negative 3. What about the fourth root of negative 81? So notice, this is an even power. When you have an even power, right, if we have negative 1 to the fourth, that's multiplying negative 1 by itself 4 times. Negative 1 times negative 1 is 1. Negative 1 times negative 1 is 1. So we get a positive number. So if you multiply a negative an even number of times, and you always get positive, or 0 if it's 0, right? When would you ever get a negative answer? Because if this ends up being something, right, we have x to what power, or x to the fourth power is negative 81. Well, this would never happen, right? Because anytime you raise something to a fourth power, to an even power, it's always positive or 0. So for this one, there's no solution. Just like how you can't do negative or square root of -1, you also can't do any even power. So the 100th root of -1 also doesn't work. The 502 of -1 doesn't work, right? Because 2, that makes it even. So you can only have a negative if it's an odd power, right? If it's an odd index. So -1 cubed, or the cube root of -1, that's okay. The 303, right? So the 303rd third root of -1, that's okay, right? You can just always bring those out. So even indexes, no negatives inside. Odd indexes, or I guess technically we would call them indices, so I should probably write it correctly. It's okay to have negatives inside. All right, so we have the fifth root of -64. Can you have a negative if it's a fifth root? Yes, 5 is odd, right? And so also, in case anybody just forgot, right? Remember, even numbers end in either 0, 2, 4, 6, or 8. So if you have a giant number, right? So 1,576,998. How do you know it's even or odd? You look at the last number. If it's 0, 2, 4, 6, or 8, it is, right? Then that's even. If it's not, then it's odd. So 5, not any of these numbers, so that's odd. So we can just bring out the negative. So 64. That's 8 and 8. 8 can be broken up into 2 and 4. 2 and 4. 4 can be broken up into 2 and 2. So how many do we have to have in a group? This time we have to have 5. So 1, 2, 3, 4, 5. So 1, 2 can come out. And we're still left with a 2 inside. So we see if we put them all together, our answer is -2 times the fifth root of 2. All right, so let's talk about multiplying radical expressions. So multiplying two radical expressions, if they have the same index, can be combined as a product under one radical. So if you have the nth root of a times the nth root of b, well, you can just put them under one radical. A times b, the nth root. Also, any coefficients in front will also be multiplied together. So if you have a number in front of this nth root of a and another number in front of this nth root of b, well, you can combine a and b into one, and then you would just multiply c and d out front. And if you notice, this is very similar to combining variables, right? So if we have 2x times 3x, well, we combine the numbers. 2 times 3 is 6. And then we combine the variables. X times x is x squared, right? Same concept. So let's simplify this one. So multiply and simplify. So you get the square root of 15 times the square root of 3. So that's the square root of 15 times 3. You can multiply this out, but you're going to have to simplify anyway, so you might as well keep it as a product. You can't break up 3 anymore. You can break up 15. That's 5 and 3. All right, well, now there's no number here. So how many have to be in a group if it didn't give us an index? So if it didn't give us an index, we assume it's a square root, so 2 of them. So these 2 3's, one of them can come out. So we end up with 3 times the square root of 5. All right, so we have a cube root and we have a cube root, so the cube roots can go together. So let's do the numbers out front first. So we have 7 and 5. So 7 times 5 is 35. And then we have the cube root of the inside, 4 times 6. So remember, we're going to have to simplify, so let's just leave it as a product. So 4 can be broken up as 2 and 2. 6 can be broken up as 2 and 3. Since we need 3 numbers in a group, notice we have 3 2's. So a 2 can come out. So we have 35 times 2 times the cube root of 3. And 35 times 2 is 70. So we get 70 cube root of 3. All right. So same thing, right? Cube root, so we can combine those. So doing the numbers out front, we get 10 times 5, which is 50. And then we can get the cube root of what's inside, so 16 times 2. Since we have to simplify anyway, we want to leave it all factored already. So 2, can't simplify that anymore. 16, that can be 2 and 8. 8 is 4 and 2. 4 is 2 and 2. So we need a group of 3. So here's a group of 3. 1, 2 can come out. So we get 50 times 2. And then we're left with 2 more 2's times the cube root of 2 times 2. So multiplying the outside, we get 100 times the cube root of 4. So let's look at 2 more examples, and then we'll be done with this lesson. So fourth roots. So since we have fourth roots, and right, here's a fourth root, here's a fourth root, so we can combine them into 1. So 8x cubed, 8x cubed y squared times 8x to the 5th y to the 3rd. So let's just look at the numbers first. So 8, that's 4 and 2, 2 and 2. 4 and 2, 2 and 2. So we need 4 numbers to be part of a group. So 1, 2, 3, 4. There's our 4. So we see that our final answer, we're going to have 1, 2 on the outside and 2 2's on the inside. All right, so now we have the x's. So x to the 3rd, x to the 5th. So when we add these two together, notice we're going to get x to the 8th. Or when we multiply, we add the exponent, so we get x to the 8th. So how can we break up x to the 8th into groups of 4? Well, notice that's going to be 2 groups, right? So that's just 8 divided by 4, which is 2. But if you want to actually see it, right, then that means we're going to multiply 8 by itself, or x by itself 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. So here's one group of 4 x's. So an x will come out. And another group of 4 x's. So an x will come out. Or, right, notice this is going to be x squared. That will be 2 of them. Likewise, we have y squared times y to the 3rd. So that's just going to be y to the 5th. So if we notice, right, y to the 5th, that's the same as y to the 4th times y. The reason why we want to do that is because 4 is divisible by 4, right? So this group of 4 x's, or 4 y's, are going to come out. And then we're going to have 1 left inside. So we see all together, we get 2x squared y times the 4th root of 4y. Maybe we can do a different color. There we go. Emphasize it a little more. All right, that might have been a little confusing, so let's do another one. All right, 4th root, so we can combine them all. So 4x squared y times 8x to the 6th y squared. Let's do the numbers first. So 4 breaks up into 2 and 2. 8 is 4 and 2, 2 and 2. We need 4 to come out. So there's 4 2's. So we know our final answer. There'll be 1 2 on the inside and 1 2 on the outside. Let's look at the x's. We have x squared, x to the 6th. So we multiply those two together, we get x to the 8th. So again, 8 divided by 4 is just 2. So we know on the outside we're going to get x squared. Then we can combine the y's. So basically this is what happens. So x to the 8 divided by 4, that's just x squared. So now we have y to the 5th. Sorry. Y to the 5th and y. So remember y is just being raised to the 1st power. So that's y to the 6th. 6 is not divisible by 4, but 4 is. So we can see that's just y to the 4 times y squared. Right? Because when we add these two together, we get 6. So this one group of 4 y's is going to come out, and we're going to be left with this y squared inside. So if we want to write a little nicer, 2x squared y times the 4th root of 2y squared. That's our final answer. All right, if you have any questions, let me know. Otherwise, have a great day.